So the next scientist was Augustin Fresnel. The usual, he was born May 10th, 1788. He had four brothers, he was the second of them. He was actually far from a child prodigy, but he was a slow learner, but he, despite that, did well, and etc., etc. In Huygens, in 1678, had proposed that light was a luminous disturbance, and that each light point became a source of disturbance. And as I stated above, Thomas Young with his double slit experiment, and that how light was a wave. Now Fresnel, unaware of Young's work, conducted experiments of his own to prove this theory, and he went one step further by making mathematical models to represent light as a wave, and made synthesized mathematical proof to match up with his physical measurements. So, his wave theory for light. One thing Fresnel stated was that light is a transverse electromagnetic wave. In other words, it oscillates, as in it goes around and around a central axis at a perpendicular direction. So what he means by that is the electric field and the magnetic field are always positioned at an orthogonal or perpendicular position. One thing to be mentioned about his wavelength, it is similar to the graph of a sine function. Now his optical experiment. So he conducted many experiments to prove and disprove nature of light. So his initial theory was that light was corpuscular. Initially, this is an image of what his experiment looked like. His experiments were based on shadows coming from an obstacle. The main thing that proved that it was not corpuscular was that his experimental results did not match his theoretical calculations. And now he also tried to explain diffraction. Two main things that are used to define this are external fringe and internal fringe. External fringe. So the thing about external fringe, it's described right here. It's formed by two rays, one from the source and the other from the edge of an obstacle. The obstacle right here, the edge of that. Versus the internal fringe is coming from both edges of the obstacle itself. That's the difference. If you need to. Yeah. Next slide. So he also synthesized this formula: x is equal to radical 2n wavelength times b plus ab over a. This formula shown above, the formula for this test would take the following form shown above, as I said. He then conducted experiments using this formula to measure the fringes that are formed, and unfortunately, his calculations and measurements did not match when he used this formula, and is another proof that light is not corpuscular. Now, Fresnel then decided to study the interference of multiple waves due to the two-point source waves. He then theorized that the intensity of light due to the interference could be mathematically calculated, which was a big step of what he did. So he then came up with the following formula presented to the right. The A and the A prime are as described here, are the intensities of the waves. The capital A is the resultant intensity. The capital U is the resultant velocity. And the vibrations at each point in the wavefront may be considered as the sum of the elementary motions. So basically what Fresnel did with his experiments was he took Huygens' hypothesis and his own principles and combined them for light interference. He would then use this to come up with multiple other formulas for vibration and sensation of the waves, and he would pursue on to conduct multiple series of trial experiments to measure intensity and strength. When he did this, his experimental values and theoretical values both came really close to each other, if they were not the exact same. And this was actually shocking to the French Academy of Sciences, who he showed his research to in 1819. So, basically, Fresnel's wave theory and the theoretical and mathematical representation, eventually it was wider accepted. He was awarded the Grand Prix for his wave theory in 1819, as stated above by the French Academy of Sciences. This submission impressed another scientist, Poisson. He initially believed in the corpuscular theory, and then after reading Fresnel's theories, he started accepting his methods. One main application of Fresnel that he used based on his wave theories was he was able to use Fresnel lens, which revolutionized the lighthouse technology at that age. Unfortunately, like many scientists that we know, he didn't receive as much recognition during his lifetime. This is another statement of his achievements. His research led to universal acceptance of the wave theory. His work Fresnel represented his work on diffraction. He entered it as a competition in 1819. There are a vast variety of applications, implementations of Fresnel's equations described above. So, one thing, life without Young and Fresnel and their applications of the wave theory. So, they both contributed to the field of optics significantly. Their contribution to light is as can be compared to the theory of gravitational force and laws of motion. The main thing about them is they changed the concept that light is not a particle, but rather a wave, and based on that, many applications like polarization, optical lenses were possible. Fresnel's equations, a main important thing they did was they helped increase the accuracy used in optical systems, and it's the only thing important. So, phenomenal progress due to their applications was made in optical devices. The medical world progressed, X-rays, sonographies, those are all due to their applications of the wave theory. So, I would like to discuss the characteristic of a wave. So, this right here, the top part is the crest. The wavelength is the distance between the crest, and the amplitude is from the reference line to the top. That's oops. This is just another representation of Fresnel's one of many equations that he used. These are my references. So, thank you.